Today, class, we're going to learn about compound interest, and we start off with three formulas, and then we'll learn one more formula at the end. But it's given here because interest grows exponentially. That's why they tell you to invest in things when you're young, so that you will have lots of money when you get old. Anyway, this is the simple interest formula, and this just says that the amount of interest is equal to P, and which is the principal. P is called the principal. That's the initial investment. How come my pencil doesn't let me write? There we go. Okay, that's the principal. P-R-I-N-C-I-P. I think that's how you spell it. Principal. R is the interest rate. Interest rate. And
T the time.
as a and T is the time, and usually that's in years. Okay.
Are you recording?
And then I'm recording. So and that's a decimal, right? So the interest rate is 5%, that'd be 0.05. And this is usually the time in years, okay? And the principal means the amount that you put in. And this formula is kind of the same thing. This is the principal. The only difference here is that instead of giving you the interest, the amount of interest you earn, this gives you the amount that you'll have in an account. And we'll see the way that works in a minute. This is the interest rate. This N is the number of times that your interest is being compounded. So if it's annually, that number would be a 1. If it was monthly, that number would be a 12. If it was weekly, that number would be a 52, right? And this number and this number are the same thing. And then and this over here, this is if it's compounded continuously, meaning every single second, that every single instantaneously your interest is making money. And you would think you would make tons more with compounded continuously, but it's not really, because you're compounding continuously, but you're also earning way less interest per period. Okay. So anyway, a credit union, it pays an interest of 8% per annum. That means per year. So that's just the way it is. Compounded quarterly at a certain savings plan. If $1,000 is deposited in such a plan and interest is allowed to accumulate in the account, how much will be in the account after 1 year? So all you have to do here is go A equals, your principal is 1,000 times 1 plus 0.08 over 1, because it's compounded annually, times 1.
Quarterly. It said compound quarterly. It's 8% a year, but
Where does
so
it say?
then-
Oh, compounded quarterly.
Really?
Sorry. So that's 4, and that's 4, and that's 1. Follow what I did?
No.
Good. It's compounded quarterly, so that's the number of times that your interest is compounded. This 4, it goes up here as well, and this 1 is for 1 year. So in other words, what you're doing, you're earning, instead of earning 8% per year, you're earning 2% 4 times per year, right? Because if I take 0.08 and divide by 4, I get 0.02, but you're getting that 4 times a year. That's why that 4 has to be here and here, right, for 1 year. Understand that? And then you just plug that into your calculator. You know how to do that, right? I don't have to do it. And you get $1,082.43. So that's how much you would have at 8%. So sometimes I'll talk about what is you'll see it like banks advertise. They say 8% a year compounded quarterly for an APR. APR, that means your effective interest rate or something like that. Effectively, you're earning more than 8%, you're earning it looks like 8.2%, right? 8.243% because it's compounded 4 times a year. But we'll do some more. Okay, so now let's go back. Any questions so far? No. Okay, so let's go to this problem now. I can hide this. Let's go to your, I have to do every one of these. This is a pain in the neck. That's okay. Determine the amount after 1 year if $1,000 in, okay, so all you have to do is put in A, but it's easy. A equals, it gets a little trickier, but not much. $1,000 at 10%, so it's 0.10 divided by 1. It's compounded annually, right? So that's 1 times per 1 year, okay? And if you do that, I believe that you get $1,100, right?
Yeah.
$1,100, right? And then if you compound semi-annually, you get 1,000 times 1 plus 0.1 divided by 2 raised to the 2 times 1. Everyone understands where that came
What's
from?
the 1 and the exponent?
What's the one? That's the number of years that this is happening for. Okay? So this is happening for 1 year, twice a year, to get 5%, right? Because it's 0.1 divided by 2. And if you plug that into your calculator, which I did, I get $1,102.50. Okay? So it doesn't make that much difference. You're making $2 more, you know.
That's a soda.
$2.50. That's a soda.
That's 3 actually if you go to the right place.
Yeah, so there. Okay. Quarterly, I'll let you do. I don't have to do all these, do I?
Yes, you do.
No, I don't.
Yeah,
Yes.
you should.
So,
Wait, do continuously.
I will. First up, let's do daily, because you would think daily you would make way more, but daily you would plug in 1,000 times 1 plus 0.10 over what?
365.
365. Okay. 0.25. No, let's just call it 365. Raised to the 365 times 1. And if you do that on your calculator, so you're getting compounded 365 times a year, but you're only getting 365th of 10% per year, you see? And so if you do that, you get $1,105.16. So not that much more, you know? And then continuously, what you have is that's, you get that the amount is equal to P, which is 1,000, E to the R, which in this case is 0.10, times T, which is 1. And if you remember, right, P, E to the R, T, okay? So this is R, which is your interest rate, and T is the amount of time that it's invested for. So if you remember, I told you that E was the limit of, as n goes to infinity, of 1 plus 1 over n raised to the n. Remember that? Okay? I don't know if you remember that, but you can see that this, as this number gets infinitely big, and this number gets infinitely big, you don't approach infinity, you approach this number E. Okay? So then if I plug this into my calculator, let me show you. You could do that, but I'm going to do it anyway. Where's my calculator? There it is. Ooh. For those viewers at home, they want to see how high-tech I am.
You're so
And
high-tech.
so, yeah. Well, I had this girlfriend, you know, way back when she was a banker. But I dumped her after a while because I lost interest.
I give you props for trying.
That was
Oh,
a-
Mr. Lee.
I thought that was a pretty good joke. I made that one up, sort of. Or I else I stole it from a popsicle stick
Hey, popsicle sticks.
Trying
to quit?
Yeah, I'm trying to
It's second, that one. Now, second, I think it's that one.
You need while skateboarding, and it's
Yeah.
like that's how you.
Okay.
Now you can
Now I can do it. So if I did this on my calculator, I would go 1, 0, 0, 0. E is above the log key. I know that. Second E to the, and this is just 0.11, right? So I mean it's just 0.1. So I plug in 0.1 in there, and I get out the answer, which is $1,105.
You make one more.
Yeah, so $1,105.17. So the difference between compounded daily and compounded continuously is not that much, right? You make a penny more. You can barely buy half a piece of gum for that much.
Look,
Okay.
annually you make like 105 more.
Yeah, compared to annually.
You make $5 more.
Compared to annually, it's better. Okay.
I'm sick of that.
So, anyway, let's move on. Hey, can't we all just get along?
Why can't
No. Okay, so, oh, that's a song from when I was in college, when I was in high school. Captain and Tennille. Why can't we?
Did you listen to that when you were smoking?
Yeah, I didn't smoke. Okay.
You said you did. Told
I-
us you did.
That's a lie. Now, let's move on. Okay, so now we're gonna figure out the effective interest rate. So if $2,000 is placed in an IRA, individual retirement account, in 2004, they'll pay an interest rate of 7% per year compounded continuously. What will the IRA be worth on January 2024? Okay? So what you have to do is you have to start off with, again, $2,000 in this case. E raised to the R, which is going to be 0.07. And in this case, this number is how many years?
20.
20 years. Okay? And if you plug that into your calculator,
Wait, isn't it like 19 years?
yeah, we're just going to call it 20 years. Yeah.
Okay.
So in that case, you get out $8,110.40.
Wait, 8,000?
$8,110.40. So that's pretty good, right? Yes? Okay.
I would say so.
And then what they want to know is what is the effective interest rate? And the way that you can do this, you can use that original formula that says interest equals PRT, right? PRT, and you want to solve this for the time. I mean, excuse me, for R, right? So how much interest did I make from $2,000 to $8,110.40?
That's 6,000.
$6,110.40. P was 2,000, right? 2,000, and R is R, and T is what?
20.
20. You guys understand what I did there? Okay? And so now I'm going to solve that for R. So I basically get $6,110.40 divided by 2,000 times 20, which would be 40,000, right? Okay? And so if I do that on my calculator, I get $6,110.40 divided by 40. Oh, O. One more. O. Hey, I sound like Santa Claus. O. Good. And I get 15. Is that much? 0.15. So the effective interest rate is 15%. Is that right?
That's a lot. Calculate it. Plug it in and test it.
15%. Well, it would have to be.
That's like 5 times what it is nowadays.
So that's pretty good, right?
Yeah.
So that's why you should invest. So you're not really making 15%. You're making 7% per year. But it's, since you're making that 7% on more and more and more and more money, right? And 15, it ends up being you're actually making 15% on your original investment, which is pretty good. I stands for the interest. R is the interest rate. This is the actual amount of interest. The actual amount. The interest rate is like 5%. So our interest rate in this case comes out to be 0.15, which is 15%, right? But the interest is $6,110, right? Yeah, the money, that actual money. Okay? So that's pretty good, right? That's why you should start investing now in pork belly futures.
Yeah.
Yeah, I don't know what pork belly futures are, but I heard that that's something you should invest in. Okay. So you can invest in all kinds of stuff. Those are called commodities. Okay, so the next thing is called the present value formula. Okay, and we still have quite a bit to do, so let's keep going. So the present value formula, it's basically the same formula, except in this case, I prefer to just use the straight up compound interest formula, but the present value formula lets you plug in the amount that you want to get to, and this gives you the amount that you have to invest, and this deals with bonds and stuff. Anyone ever get a savings bond or something like that from your grandparents? Say, okay, this is going to be, it's kind of a cheap way to let you guys think they're giving you lots of money. You go, here's your $500 savings bond, but they don't pay $500 for it, right? That's how much that bond is going to be worth after it reaches maturity, you know? And so this is how much you pay for that savings bond, and this is how much it will be worth. So a zero coupon, I don't know what a zero coupon non-interest bearing bond is, but it's, I guess, some kind of savings bond. Can be redeemed in 10 years for $1,000. How much should you be willing for it now if you want a return of 8% annually? So again, all you do is plug in the numbers, okay? And so you go P equals A, which is 1,000, 1 plus 0.08 over 12, because it's compounded monthly, raised to the negative 12 times 10. Everyone with me there? Yeah? Okay. And then if you plug this into your calculator, you get out $450.57.
Why not just the
So-
negative 12 on the top exponent?
What?
Why just the negative 12 on
Because really what you're doing, that makes it so that you're dividing rather than multiplying. You know how a negative exponent is 1 over that? And so it allows you to solve for this instead of putting this over here and then solving for this.
So it
It's
tells
just,
you how much money you have to put in to
Right,
see how,
right.
okay.
so in this case, that she pulled aunt of yours or whoever she was, she just paid, she goes, here, Johnny, you get, here's $1,000, but she only paid $450. $1,000, okay? And this works the same way. I'm not going to do this one, okay? You just plug into this formula instead.
Wait,
Yes,
where it says P equals A.
yeah,
Is that, how is that any different than A equals P?
because in this case, you are figuring out how much you pay. Say this bond is so in this case, this would, so just plugging in what you would do. P equals 1,000 E to the negative 0.07 times 10. And that would tell you how much you paid if it was compounded continuously at 7%. Okay? Get it?
Okay, but like,
Wait,
What?
so are you saying you could do either one? Like of those?
No, not for this one. It's, oh, whoops, 7% compounded monthly. I'm sorry.
So would it be the same thing as last?
Let's do this continuously. Let's change this to continuously. Okay? There you go for continuously. Because then it wouldn't be exactly the same. Okay? All right. Next thing, and these come up a lot. What annual interest rate compounded annually should you seek if you want to double your investment in 5 years? So, and this isn't talking specifically about this, is just talking in general. So the way you can do that, you can say, using the first formula, 2 times A goes over here, right, is equal to, well, it's really 2 times P. 2 times your principal is equal to the principal times 1 plus R over compounded annually, right? So it'd be 1 over 1 raised to the 1 times 5. You guys understand where I got that from?
wait,
You wanna-
Why is it P times the P? That's not basically just P squared.
No.
yeah, what about second P just be 1,000?
Yeah.
No, because this is a totally different problem. I mean, you could put in a number here if you want. You could put, it doesn't matter what number you want, what you have here. But basically, this number needs to be double this number, because you want to know how long it will take to double your money, right? So you could call this 1,000 and this 500. You don't want to know how long. You want to know the interest rate. Okay? So solving this a little bit, what could I do with both of these p's? You can cancel them out, and now you have to use logarithms. Yay! Okay. So you want to solve. Oh no! In this case, we don't have to use logarithms. So you go 2 equals 1 plus r, right? Because r over 1 is just r, raised to the 5th power. And then to get r by itself, what I do is I take the 5th root of both sides. So I go the 5th root of 2 equals 1 plus r. And do you know how to take the 5th root on your calculator?
No.
You could either, there's either a 5 root, or you can raise that to the 1 over 5 power equals 1 plus r. Okay? So taking the 5th root is the same as raising it to the 1/5 power. And so then you go to your calculator and you go, come here again. You go 2 raised to the, in parentheses, 1 divided by 5. And you get some number. You get 1.14, and then I have to subtract 1 from that, minus 1, and that is equal to 0.14. Okay, so r equals, what was it, 0.14 what? 0.148. 0.148 for about 14.9%. Okay, so if you want to double your interest, double your money in 5 years, you're going to have to earn an annual rate compounded.
What is that little symbol next to 5?
What is that symbol next to the 5? This?
Yeah, no,
This?
what's the little V?
I know.
Oh, it's 1 over
That's
5.
first, it's like,
Okay,
Your one
so
is diagonal.
1 divided by Wow. That's even worse. Okay, 1 divided by 5.
Just stop while you're ahead.
1 divided by 5. Good. Good enough. Okay, so you would have to make 14.9% compounded annually if you want to double your money in 5 years. Okay? How long will it take you to double for an investment? So in this case, now I believe you have to solve for an exponent. Okay? So in the next case, and I'm just going to do this last one. Okay? How long will it take? How long will it take for an investment that earns 5% compounded continuously to double in value? Okay? So let's do the triple in value because it's kind of the same idea. So in this case, you have 3 times your principal is equal to your principal, right? E raised to the 0.05 t, right? Easy. And then you can cancel these out, and you get that 3 equals e to the 0.05 t. And does anyone remember from that previous quiz? How do I get rid of that e? What's the inverse of e?
Natural log.
Natural log. So if I natural log both sides, okay, what I get is that the natural log of 3 equals 0.05 t, and then I divide natural log of 3 by 0.05, so I divide both sides by 0.05 by 0.05, and I get that t equals natural log of 3 divided by 0.05, so I'm going to do that. Natural log of 3 divided by 0.05, and I get, whoops, I need another parentheses here. Do I need another parentheses?
No.
I don't know.
Parentheses is not doing anything.
Why is it deleting things?
It's second insert.
Oh,
Second
second insert.
Second delete. Yeah.
How can it stop going?
It is, you just,
Oh, God.
Yeah.
Just delete it again.
Delete.
second delete and then you start
Yeah,
typing.
now you're good, just go ahead.
0.05. There. And if I hit enter, I get that, that's a lot, right? 21.97%. So how long?
Time.
29.97 years, I'm sorry. Okay? So how long will it take for an investment that earns 5% compounded continuously to triple in value? So it'd take 22 years, right? But still, that's not that bad. So even though that's not a very good interest rate, still in 22 years, if you invested down $10,000 at 5%, in 22 years, you have $30,000, right?
It's a
And probably if you invest in stock market, historical returns are more like 8 to 10%, so you make way more than that.
Actually, the whole punch these fine.
Oh, I did some of them. Okay, so your homework is on there.